Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we'll be discussing a problem on wedge friction, and it's a topic of engineering mechanics, and the lecture series is 3-4. Let us look at this problem. Here, what force P must be applied to the weightless wedge? This is what is the green color. It's given that it is a wedge, weightless wedge, to start moving under 1000 Newton block, and the limiting angle of friction is given 10 degrees for all contact surfaces. Let us look at this problem. Observe carefully. You have wedge. First, let us understand what is the wedge. Wedge is, you have a small piece of material. It's a small piece of material. One surface is inclined with respect to the other surface. Bottom, you see that it is horizontal, and the top surface is inclined. So it's exactly matches with this. So this is usually the purpose of this is a small piece of material, especially in engineering applications, like when you want to go for alignment of precast beams and maybe heavy machinery. You want to lift very small vertical distances. In that case, you will be going for wedges, which is not possible by any machinery. So that is the importance of the wedge. Wedge is a small piece of material, and one surface is inclined to the other, and it is used to lift the heavy weights. Here it is a weight of 1000 newtons is given, and by means of applying external force, this particular weight is to be lifted a small vertical distances, and that is the purpose of the wedge. And because this the contact is maintained because of the frictional force. So this is a problem of friction and wedge friction. And this particular problem, you can observe carefully. You have two wedges, two identical wedges, and the angle is 15 degrees and 15 degrees, and you have a block of 1000 newtons. The force applied is P, and the force is both sides, it is same. So that is the given configuration diagram. And the general procedure to solve any wedge problem, here look at that. The procedure to solve the wedge problem, I have given that the very first step of the problem is free body diagram of the wedge. Draw the free body diagram of the wedge, because you would like to know that the direction of the frictional forces. When the force is acting, maybe if you consider left side wedge, it is acting like this. The frictional force will be opposite direction, frictional force will be opposite direction, so that you will be able to draw the free body diagram of contact block that is exactly in opposite direction you are going to incorporate. So the purpose of this is the very first step is free body diagram of, draw the free body diagram of wedge, that is this. And then second step is free body diagram of block. After drawing these two free body diagrams, you will be analyzing block using either equations of equilibrium or maybe using Lami's theorem. So you will be using Lami's theorem when you have number of forces are only 3. So remember that when you have only 3 forces, you can go for Lami's theorem. Otherwise, you have to go for equations of equilibrium. And you are analyzing the free body diagram of the block. After drawing free body diagram, you are going to analyze this, and your purpose is you want to calculate the contact force between the block and the wedge. After knowing this particular contact force, again you are coming back to the wedge, and you are analyzing that using equations of equilibrium, so that you will be able to find out the external force required, that is P value. So here, after using Lami's theorem, again you are going to calculate the contact force. The other method is, again you are applying Lami's theorem to the wedge also. When you have 3 number of forces, the number of forces are only 3 concurrent forces, so that you can make use of Lami's theorem. So here this is pure your option. Remember that either you can make use of equations of equilibrium, or you can make use of Lami's theorem. Remember that Lami's theorem is applied only when you have 3 forces. The number of forces are only 3. Then only you can go for Lami's theorem. That is the limitation. But in this particular problem, because the number of forces are 3 in both the cases, in block as well as in wedge, we'll try to solve this problem by both the methods. so that you can understand thoroughly the problem. So let us just adapt the procedure blindly for any problem. So free body diagram of wedge. Let us draw the diagram of the wedge. I am drawing diagram of the wedge. Let us look at here. Let me take somewhere here 15 degrees, and the force is acting to the right. Let us incorporate the normal force. I am calling the bottom normal force as N1, and here when force P is acting, the impending motion is to the right. The frictional force is the direction is here the F1 is exactly opposite to the impending motion, and immediately replace this F1 and N1 with R1. R1 is the resultant of these two forces. Remember that R1 is the resultant of F1 and N1. This angle, as it is given in the problem, 10 degrees. It is angle of friction. This is 10 degrees is given in the problem. So the bottom contact surface, you have drawn the free body diagram, and it is in contact with the block also. The external force or the reactive force exerted by the block, your, let us call it as N2. So this is at an angle 90 degrees, remember that. And this is tending to move as it is moving to the right, and you can incorporate the frictional force opposite to this you can call it as F2. And this inclination, as it is given 15 degrees, with vertical it is 15 degrees, and resultant of these two, that is R2, I am calling it as R2 at an angle 10 degrees, that is phi, which is given in the problem. And this completes the free body diagram of left side wedge. So because this is identical, and you can go for analysis of only one wedge, but to have more clarity, I am drawing both the wedges, the free body diagram of both the wedges. Let us understand thoroughly. And this is also, the force is like this P. So here it is, let me call N1, N2, and this I am calling it as N3, and it is tending to move to the left. The frictional force is to the right. So this is F3 and R3. R3 at an angle phi, limiting angle of friction, that is phi, that is given as 10 degrees. And here the normal force, let me call it as N3, and this is N4. I'm calling it as N4, and here the motion is to the left and frictional force is to the right. Let me call this as F4, and the resultant of these two is R4 and at an angle phi. You have drawn the free body diagram of wedges. I have drawn both the wedges. This is an identical problem, but the free body diagram of one wedge is enough to solve the problem. But to have more clarity, I have drawn both. Now, second step is draw the free body diagram of block. Let us draw the, I am drawing little above because you can understand thoroughly the direction of the force. So let me draw the free body diagram of block. Right here, the weight is 1000 newtons acting downwards, and exactly here, observe carefully, the left side wedge is in contact here. You have normal to it. This angle, as you know from geometry, it is 15 degrees, and this force, observe, look at this, R2 is inclined at an angle with vertical 15 plus 10, 25. So you can mark this at an angle, it is R2 at an angle 25 degrees. This angle, total angle is 25 degrees. It is 15 plus 10. 10 degrees is angle of friction. Similarly, because it's a symmetric, obviously you have this force is R4, and with vertical it is at an angle 25. So this completes the free body diagram of block. That is your, this is second step. Let me call it as a free body diagram of block. And this is first step, free body diagram of wedge. And after the second step, I am using equations of equilibrium. Let me solve this problem by in the beginning using equations of equilibrium. Let me take a division, and my third step is in this is using equations of equilibrium. Let us look at this. Apply equations of equilibrium for this free body diagram. Let us make use of sigma fx is equals to 0. Sigma fx is equals to 0, and the component of R2 along the horizontal, it is R2, and this angle is included angle is 25 with vertical, so horizontal component will be sine, it is 25, and it is pointing to the right, positive, minus it is R4, this force component, it is minus R4 sine 25 is equals to 0, and from this you are going to get that from symmetry also you can conclude that both are equal. Your R2 and R4 are equal. That is what is sigma fx. Now write down what is sigma fy. You are interested in contact force. Sigma fy is equals to 0. So it is you see that R2 and R4 both are equal. The vertical component is, you can write down 2 times, it is R2 cos 25 minus 1000 is equals to 0, and you can calculate R2 value, it is 1000 divided by 2 cos 25. So this you are going to get 552 newtons. You got that R2 value, it is 552 newtons. This is the analysis, that is third step. Using equations of equilibrium, you got that contact force is R2, and that is 552. So the last step of the problem, that is fourth step, is again it is using equations of equilibrium on wedge. So you want to apply equations of equilibrium on wedge because this contact force is known. Write down sigma Fy is equals to 0. Sigma Fy is equals to 0. The moment you write down sigma Fy, there is no component of the force P in this equation. You have R2, it is R2 cos 25. The projection of this on this R2 cos 25 is equals to, or it is you can use as minus R2 cos 25 plus it is R1 cos 10 degrees is equals to 0. From this you can calculate R2 is known. If you substitute your R1 is equals to R2, that is 552 cos 25 divided by cos 10. So this value you are going to get 508 newtons. You got R1 and R2, and you can simply make use of sigma fx is equals to 0. So this equation you can write down, it is a P is positive, which is pointing to the right, and it's minus R2 sine 25, the sine 25 minus R1 sine 10 is equals to 0, and you are going to get because R1 and R2 both are known, R1 as well as R2 are known, P value you can calculate this, you are going to get 321 newtons. This is the required answer, that is the external force required in order to have impending motion. This is one method of equations of equilibrium. Now the same problem you can solve using Lami's theorem also. So let me make use of this Lami's theorem, which is simpler to solve, and whenever you are using Lami's theorem you need another diagram, that is coordinate axis diagram. So in third step, let us draw the coordinate axis, that is you are going to draw this, and let us represent here 1000 newtons, and you see that R2 with vertical 25, This is R2. It is angle is to the right, and it is R2 at an angle with vertical 25 degrees. And see that R4, which is also inclined with the same angle, that is 25. So this is R4. So let us calculate, whenever you are applying Lami's theorem, angle between the two successive forces. The angle between these two is 180 minus 25. It is 155 degrees, and this is also of course 155 degrees. Now you got all the angles. Now you can make use of Lami's theorem. Remember that you are very much interested in R2. So this R2 contact force. So you can simply write down R2 divided by sine of angle between the other two forces, that's sine of 155, is equals to known force, that is 1000, divided by the angle between the other two forces. Sine, this is the angle and it is 50. You can write down sine 50 degrees. So from this, you can calculate R2 value. You are going to get 552 newtons from Lami's theorem. Just cross check. You got the same value using equations of equilibrium also. Now, lastly, the fourth step, again, you have to represent again all the forces on coordinate axis. Here, see that it is P is horizontal force to the right. This is P, right? And here R2 is acting downwards with vertical at an angle, 25. So this is your R2, right, at an angle 25 degrees. And see that R1 is to the left at an angle 10 degrees. This is R1 and angle is 10 degrees. Now you can calculate the angle between the forces. This angle, it is 10 plus 90. So this angle is 100 degrees. And this angle, it is 180 minus 25, 155, 150 minus 10, it is 145 degrees. And see that it is 90 plus 25, 90 plus 25. So this angle is, 115 degrees. Simply, you can use Lami's theorem. You are interested in P value, P divided by the angle between the other two forces, sine 145 is equals to, and the known force R2 as it is 552 divided by sine of angle between, it is 552 R2, the angle is 100. And from this you can calculate the P value. Your P value, you are going to get 321 newtons. Observe carefully. Either you can make use of Lami's theorem when you come across with the three forces. Remember that when you have only three forces, you can apply Lami's theorem, and you need to draw a separate diagram such that all the forces are diverging and you have to find out the successive angles, and so that you can calculate the unknowns. Here you can make use of equations of equilibrium in general for any problem if you have any number of forces. I hope you have understood this problem. Thank you very much for watching this video.